Hello and welcome to Potential Dividers, Level 1. Let's get a few problems, starting with this one. Right, standard potential divider problem. You can work out the current that's flowing down through these two resistors. And that would be, in this case, 640 millivolts divided by 4 meg 3 plus 10 meg. And if you know the current flowing through these two resistors, you can work out the voltage across this resistor by Ohm's law. It's just the current times the resistance itself times 10 meg. Don't know why I typed it down there. I could have typed it in here. It's the answer. Great. Next. What reading will the voltmeters show? Well, same type of idea. 8.6 volts. You divide by the total resistance to get the current. I could have written 1K2, but I didn't. And then you multiply by the resistor here that you want the voltage across. That would be times 1K2. And that tells you the voltage. Good so far. What reading would this voltmeter show? Same idea. 410 microvolts this time, divided by a total of 22 meg plus 4 meg 3 multiplied by 22 meg. So this is the current flowing through this resistor. This is the value of this resistor. Ohm's law says the voltage across them is the product of the current times the resistance. So that should be the answer. Great. Just do one more. An interesting one. Set the resistor values so the output is 0.833 times the input. Now, if we want this point here, x, to be 0.833 of A, then what we need from these two resistors, if we call this one R1 and this one R2, is that the total current flowing would be A divided by R1 plus R2, and you multiply that by the value of this resistor here, which is R2, and that should give you X. Now, what we want is for X over A to be 0.833. Right, let's have a look at that in a bit more detail. If I take this formula here and rearrange it a bit, I would get X over A, that's dividing both sides by A, is equal to R2 over R1 plus R2, and I want that to be equal to 0.833. If I take this equation and just invert both sides, then that would be R1 plus R2 over R2 equals 1 over 0.833. And 1 over 0.833 is 1.2. In other words, R1 plus R2 must be 1.2 times R2. Subtract R2 from both sides. R1 equals 0.2 times R2. And it doesn't matter what the values are, the absolute values, provided the ratio of them is 0.2. To express that another way, 5 times R1 is R2. Just multiply both sides by 5. So R2 must be 5 times bigger than R1. Right. Back to here. Doesn't really matter what the values are, so I could just set that to 5k. And then it's 5 times bigger than this value here, and I'm done. Excellent. I'll just do another one like that. This one, we've got 0.87 times the input. Same idea, go through the same type of calculations. You'll find that instead of 0.833 here, we get 0.87, and 1 over 0.87 is 1.15. So this here would become 1.15, which means this here would become 0.15. R2 is 0.15 times R1. So, back to the problem. If this point here is 0.15 times this point there, I could just make that 150 ohms. then it would be 0.15 times 1,000, and I should get the right answer. Great. Okay, that's enough for level 1.